Have you noticed that the climate seems to be warming much more quickly than anyone expected? More droughts, more heat waves, more floods. The ice sheets are certainly melting more quickly than forecast. Even NASA is concerned. Do you think there might be a problem with the climate science? Well, in this video we're going to look at how, although the amount of heating that the Earth is experiencing is right in line with forecasts, even those made 35 years ago, it's having much bigger impacts than anyone expected. And then we'll look to see how the scientists are trying to rely on the climate models much less than have done so far, and trying to find new ways to forecast where we might be heading to, because the climate models aren't as useful or as accurate or as solid as maybe we hoped they would be. But first of all, because this is a video about the climate science, you have to become a climate scientist, and I can help you to become that by telling you all about zero-dimension energy balance models. At the very highest level, it's quite easy to calculate Earth's climate. It's floating in space. We know how much heat energy it receives from the sun every day in terms of shortwave infrared radiation. We know how much of that radiation is reflected straight back into space by the ice sheets or by the clouds. We're in this field, by the way. Clouds are the official background today, so we know about the clouds reflect the heat back out. We know how hot planet Earth is and how much long wave infrared radiation it reflects back into space. And lastly, we know how much CO2 and greenhouse gases there are in the atmosphere. We know the effect of clouds in trapping heat on Earth. So you put that all together. I'll put it in a spreadsheet on my phone, which I'm now calling a climate model. You put all the values in and it comes out at 15 degrees Celsius, which is the right value. The average surface temperature on planet Earth is 15 degrees Celsius. This very simple equation can calculate it for you. And if I was to take out the value for greenhouse gases and clouds, then we get a value of minus 18 degrees Celsius, which is also correct. If there weren't any greenhouse gases, Earth would be an enormous ice ball. And although you might only be learning this now, intuitively we all know it, don't we? A sunny day is warmer than a cloudy day, because on a cloudy day the clouds are reflecting the shortwave infrared radiation from the sun back out into space. And at night time, even though there's no sun, we still get some warmth from the Earth as it gives off its long wave infrared radiation. And we know a clear night is colder than a cloudy night, because the clouds reflect the long wave radiation back down to us and keep us warmer. When you've got your climate model based on your beautiful pure mathematical principles, you compare your results to the climate you can see going on around you now, or in the recent past that scientists have been able to measure, maybe weather reports and things like that. And also you compare your model to the paleo science. You take, for example, ice cores from the ice sheets, and you analyse the gases that are trapped in them, and that allows you to see what the atmosphere was like thousands of years ago. Or you can analyse the isotopes of oxygen that sea creatures use to make their shells out of calcium carbonate, and that's a way of judging temperatures maybe millions of years ago. Plus you can look at things like sedimentary rocks, and you can see what the ocean currents were doing when those rocks were laid down again millions of years ago. So you have your pure mathematical model, you understand what the climate's doing now and what the climate's doing in the past, how the Earth's physical systems are changing and how they work, and you try and get your model to match them as accurate as you can. Well done, you are now an official climate scientist. So, 35 years ago, Professor James Hansen was one of the first climate scientists to say not only is climate change happening, but it's being caused by humans. He presented it to a United States Congressional Committee, and although his climate model was comparatively simple compared to today's ones, 35 years later his predictions in how temperatures would increase are surprisingly accurate. And that's partly because, I think, when it comes to calculating the amount of heat that the Earth is experiencing, It's a beautiful mathematical calculation, as we had in our zero dimension model. When it comes to calculating the impacts it will have on Earth, that amount of heating, it's much more complex. So first of all, you have to work out how much heat energy the oceans or the land surface is experiencing, and that's measured in watts per square metre, and scientists call that how much forcing the oceans or the Earth are experiencing. And then you have to work out how much that heat energy will lead to a temperature increase, and the heating is measured in degrees Celsius, and that heating that results from the extra energy might not happen straight away. There could be a delay, it might not be obvious, and then that increased warmth in degrees Celsius, that leads to changes in the Earth's systems. So it could be more rain or less rain, changes to the ocean currents and the currents in the atmosphere, melts the ice sheets, and then there's another delay before the Earth's ecosphere is affected. So the corals, the Great Northern Forest, the permafrost, the Amazon rainforest, and then finally, which is what we all want to know, is what happens to humans. And you have to repeat that year after year, and any misunderstandings or mistakes in the model, year after year, as you calculate it all, any small problem in the long term can have much bigger impacts and makes the models much less likely. And in fact, the latest report from the United Nations says it's much more difficult to forecast the impacts on planet Earth for scenarios where there's high carbon emissions and great deal of heating and further into the future. And for this video, every time I say the United Nations says this or that, what I'm really referring to is the United Nations Intergovernmental Panel on Climate Change Assessment Report number 6, Working Group number 1, and that's all to do with the physical aspects of climate change. But when climate science started off, the only questions people asked the climate scientists was, is climate change happening, and is it being caused by humans? But now climate change has become a much more urgent, much less distant philosophical question. People have much more specific questions, you know. Will my part of the world be habitable? Will there be any food? Those are the things that it's only until recently the United Nations has started to report on. So in the most recent version of its climate report, 2021, it's the first time they ever broke down their report into regions. Until that was just global. It's much more difficult for the models to calculate things at a regional level, and also to calculate extreme weather events. For the most part, climate models were not designed to predict regional extreme events. Their main task is to simulate average temperature changes across long time periods and wide areas. Researchers are well aware of and have always been clear about the shortcomings of climate models. They remain rough computer simulations limited by human understanding of the climate system. This makes a difference because Europe, for example, is warming twice as quickly as the average. The Arctic is warming 4 times as quickly. Last year I made a video where I included a section from a news item where a weather person said in 20 years time we could have 40 degrees Celsius weather in Britain, and all the problems it would have. A few weeks after that video we did have a 40 degrees Celsius day. It's only when you break things down into regions that you can see these possible extreme weather events more clearly. And so far we think the extreme weather events are in line with expectations, but it will take a while to find out because you don't get extreme weather events very often, so you have to wait a little while to see if there's a pattern. Anyway, here's what the United Nations says about what does it say? About how the rate of warming is already impacting Earth. Climate change has altered marine, terrestrial and freshwater ecosystems all around the world. Effects were experienced earlier and more widespread, with more far-reaching consequences than anticipated. Since the Earth is being impacted much sooner and to a much greater extent than the scientists forecast, the one concern people have is tipping points. And a tipping point is where a small change to the climate, for example a small amount of warming, causes a great change in one of the Earth systems or part of its ecosphere. And it's a problem because if, for example, the Greenland ice sheet went past the point of no return, it's quite a massive piece of ice, it will take hundreds, maybe thousands of years to melt. But as the temperatures warm, sooner or later, and it seems now sooner, it will reach a point where it will just carry on melting. So it's melting now at 1.2 degrees Celsius of warming. We're heading for at least 1.5, probably 3 or something like that. It will start melting much more quickly, and in fact it will transition to a new state. It won't just be getting slightly smaller and smaller, it will collapse and it will transition to a new state of not being an ice sheet. That will stop reflecting the shortwave infrared radiation back into space, lead to more heating, so that's a positive feedback. We can't do anything about it, and because it leads to a fast change, or a faster change to just the normal increase from CO2 emissions, it's much more difficult to cope with. Well, 20 years ago, it was thought we wouldn't have to worry about tipping points until we reached maybe 4 or 5 degrees Celsius. But because it's been realised that the climate is impacting the Earth much sooner than people predicted, it's now thought that we could be having tipping points right now. And this is something I've noticed. Scientists are much better at saying we've reached a stage now where this might happen. They're much better at saying that than they are saying in 20 years this might happen, because looking into the future with climate change is very difficult to do. We'll look at one example, which is the ice sheets. They're melting more quickly than expected, and one of the reasons for that is we can't do it in a beautifully pure mathematical way. You have to understand the physics of how ice sheets melt. At one time, the West Antarctic ice sheet and the Greenland ice sheet were just lumped in together. They were just ice sheets. But now people realise they're different ice sheets. The West Antarctic ice sheet terminates in the oceans, so they have water washing against them, undermining them, increasing the rate of melting. The Greenland ice sheet terminates on land. And to understand how the Greenland ice sheet will melt, you have to understand how ice cliffs collapse. And then once those small ice cliffs at the edge have collapsed, how the bigger ice sheets further back will start to collapse. On the ice sheets themselves, where the water's melted, it's sort of made channels that go right to the base of the ice sheet. They're called moulins. That water sort of lubricates the bases of the ice sheet. It slides towards the edge more quickly, warms more quickly. Also, on the surface of the ice sheets are rivers of ice called glaciers. At the moment, they're held in by ice at the edges of the ice sheets, and that's called buttressing. As those buttresses melt and collapse on the edge of the ice sheets, those glaciers, those rivers of ice, will flow much more quickly. So the worse it gets, the worse it gets. So let's see what the United Nations says about why it was difficult to predict how the ice sheets will melt. They really changed their way of thinking. Until a little while ago, they thought the worst case scenario for sea level rise was nearly a metre. Their latest forecast is we could expect 2.3 metres of sea level rise by the year 2100. Everyone always goes to the year 2100. And they say if you're responsible for planning sea defences, you might want to plan to have a higher level of sea rise than 2.3 metres. So here's what the United Nations says. It says they've got limited published studies to draw from, and no simulations run beyond the year 2100. It's very expensive to run computer models. People tend not to run them past the year 2100. And even if they did, from how difficult it is to predict how the Earth will be impacted 70 years in the future, or 80 years in the future, there wouldn't be so much benefit in doing it anyway. Because of our limited understanding of the rate at which some of the governing processes contribute to long-term sea level rise, we cannot quantify the likelihood with which they can cause higher sea level rise before the year 2100. The main uncertainty related to high-end sea level rise is when, rather than if, it arises. The scientists say we've only got a very limited understanding of how these things work. There's a lot of uncertainty, and in some ways they're saying it doesn't matter because it's going to happen. The only thing we have to calculate is when it will happen. So you need to be ready for it anyway. It's going to happen. And it sounds very shaky, doesn't it? If you don't get this in the news, do you? Assessments of ice sheet contributions based on structured expert judgment. So they're not relying on computer models, but they're relying on professional experts who know the science, and they're taking their best guess of what it might be. So expert judgment leading to a 95th percentile of projected future sea level rise as high as 2.3 metres in the year 2100. Well, at one time, if you saw a United Nations graph, and normally it has a line going up, could be temperatures, sea level, CO2 concentrations, but they always have a line and it's always going up, zigzag fashion. And then either side of that line, they always draw in a grey shaded area and they say, this is the likely range, or we'll just plan for having our line in the middle, that will be the range. And anyone who suggests it could be as high as the highest likely range is sort of condemned as some dangerous extremist. That's not the approach the United Nations is taking now. They've seen that the climate is changing in line with expectations, it's impacting the Earth much sooner, and so they've sort of lost their confidence a bit and they're being much more cautious. Well, the Thames Barrier was designed to cope with a sea level rise of 50 centimetres, of half a metre. It's going to be quite a big change, isn't it, to upgrade that barrier, the Thames Barrier, to protect London by another 2.3 or maybe even 3 metres if you go higher, and you have to increase the seawall all the way along the coast, or all along the Thames, right from the coast right into the city of London. And that's just one aspect of climate change. So how is it then that the scientists no longer feel they need to stick to what their models tell them, or the middle route, but they're now considering these sort of more these higher scenarios? Here's some research, and it's all about a new way of doing things called storylines. As the scientific discussion shifts from whether climate change is real to the evaluation of regional impacts and response options, the limitations of approaches to physical aspects of climate change are becoming increasingly apparent. And here's the reason they think that the models have limitations. Climate models have structural errors, many of which are shared, which challenges a probabilistic interpretation of multi-model ensembles. For the most recent United Nations Climate Report, Assessment Report number 6, they received the runs from 100 different models from 48 different modelling groups. And normally when a scientist publishes some research, it's subject to peer review, and experts look at it and try and understand if it's accurate or not. Maybe they'll try and recreate the results themselves independently. That's not what happens here. They just take the average. You have 100 models. They're not really clear what models do what, or what the models include when they do their calculations. Well, science isn't a democracy. 2 + 2 = 4, whether you like it or not. If only one of the models was accurate, you'd only need that one model. But they don't really get into that. They just take like the average, although they do, in the past, they have removed some models because they weren't even able to correctly recreate the 20th century. But basically they don't look into it. So, but there's much bigger structural errors than just a few minor differences between the models. Here's something by Professor Michael Mann, and he's the chap who coined the term the hockey stick graph. Okay, so he says fast feedbacks do not, for example, include the slow retreat of continental ice sheets or the slow response of Earth's surface properties and vegetation. There is good evidence from long-term geological records of climate change that these slow feedbacks do indeed matter, and that the ultimate warming and associated changes in climate might be substantially larger than what is implied by the definition of sensitivity implicit in the IPCC projections. And that seems to me an important aspect of Earth systems, how the ice sheets are melting. They're considered to be a slow feedback because in the past they've taken a long time to melt. So since you only ever look to the year 2100, you can see why they might be ignored. But given that the humans are heating the Earth much more quickly than anything we've seen in the past, maybe they should be included. That's what Professor Michael Mann thinks. And then we have a concern from Professor Sir David King. He was at one time the UK government's chief scientist. You may have seen in a previous video, he's concerned that if all the methane in the permafrost was to be released when the permafrost melts, and the permafrost is starting to melt, if all of that methane was released into the atmosphere, that would cause warming by itself of between 5 and 8 degrees Celsius in the long term. It might take hundreds or thousands of years to melt altogether. So let's see if the United Nations includes that in their modelling. Additional ecosystem responses to warming not yet fully included in climate models such as CO2 and methane, CH4 fluxes from wetlands, permafrost and wildfires would further increase concentrations of these gases in the atmosphere. So they're not yet fully included. One of the two biggest Earth systems, which are already being affected by warming, are not really included in the models. As regional climate phenomena, such as storm tracks, respond differently to climate change in different models, a multi-model mean can lead to a washed-out response that does not correspond to any model simulation. Really, they don't have any confidence in the models at all, do they? Bias correction requires a vast amount of data that may not exist. In any case, it is not known how to correct model biases in simulating climate changes. Estimates of uncertainties at the regional scale can quickly accumulate to the point where this knowledge hinders. So there are problems with the models, but we don't know how to fix them. And therefore, in the most recent United Nations climate report, where they have scenarios of deep uncertainty, even if there's a low likelihood, if there is a high impact outcome, like will there be enough food for humans, then they're starting to use these scenarios to try and understand, if it did happen, what would be the impacts, and also how you might be able to spot it was happening. You know, if you always stick to the middle line in your graph, then you're sort of blinding yourself to the more dangerous possibilities. Low likelihood, high impact outcomes could occur at the global and regional scales, even for global warming within the very likely range. Well, that's business as usual, isn't it? We're getting the expected amount of warming, which they seem to be able to correctly forecast, but it's the impacts they struggle to fully understand. The probability of low likelihood, high impact outcomes increases with higher global warming. Yes, and that's true. Not only because you've just got more warming, so we're in a more dangerous situation, but also the Earth systems and the ecosphere are affected more, so it's much more difficult for the models to fully understand what might happen and to allow for that. Abrupt responses and tipping points of the climate system, such as strongly increased Antarctic ice sheet melt and forest dieback, cannot be ruled out. We're already at a point where the tipping points could happen, and included in tipping points, if I just zoom in a bit on my little picture, tipping points that we're already in danger of encountering include the Greenland ice sheet, the West Antarctic ice sheet, coral and the boreal permafrost with all that methane. And you might be thinking, who is Tim Lenton, whose slide I'm using? Professor Tim Lenton, he is the Director of Global Systems Institute at Exeter University. I'll make sure Tim Lenton gets his full acknowledgement later on in the video, so don't worry about that. This is a good thing, because suddenly, if you don't have to be 100% sure that something's going to happen, but you just think it might, suddenly it gives you the freedom to explore it, to raise it as a concern. And one example might be human extinction. So if you ask Professor Michael Mann, are humans going to become extinct? He says there is no evidence that humans would become extinct because of the climate scenarios we know at the moment, which is true. Probably because nobody ever runs the models past the year 2100, but that's true. But in this new way of thinking, I don't have to say my climate model can prove humans will become extinct. All I have to say is 252 million years ago, between the Permian and the Triassic periods, there was a great period of warming. 2/3 of the land species became extinct. The current rate of warming on planet Earth is faster than that, and it's quite possible the actual amount of warming will be greater than that depending on how the climate changes. So all I need to do is say this is what happened in the past in the paleoscience, which you should always compare your models to. And therefore there's a risk of humans becoming extinct. Sometimes I get comments from people saying the United Nations always understates the problems, maybe it's been politically interfered with, and we'll see that in a later video what political interference goes on. But just for this one, we'll just do it on the science. And they say the scientists in the UN never really tell the truth, they never tell us how serious it is. But I think they do, but they just word it in a very conservative way. So for example, such low likelihood high warming outcomes are associated with a potentially very large impact such as high risks for human and ecological systems. High risk to humans, the end of civilization, the collapse of societies, extinction. When it comes to melting ice, at least you know it's only going in one direction. There are much more complicated problems to try and understand. For example, currents in the oceans or currents in the atmosphere are much more difficult to forecast. One concern is called the El Nino Southern Oscillation. And when you run the models, some of the computer models say in the future, as the planet warms, we will have a more El Nino type of climate. And some models say we shall have a La Nina climate. Well, depending on what part of the world you live in, an El Nino or a La Nina type climate could cause more rainfall, less rainfall, more heat waves, fewer heat waves. The models can't tell us which it is. And if you live in India, you might like to know, because the Indian monsoon partly depends on it. And if you don't have a monsoon, then you don't have enough water to live. People in the United States might want to know whether it's going to be La Nina or El Nino, because they'd like to know what parts of the United States will still be able to grow crops. At the moment, the models aren't able to answer these questions. The models do not show any clear consensus. Most models predict an overall more El Nino-like climate. However, a few of the other models predict the opposite, a more La Nina-like pattern. One might be tempted to go with the majority. That's not really how science works, it's not a democracy. The El Nino trending models. However, paleoclimate evidence of the response of ENSO to the past natural changes suggests the possibility that the minority of models that predict a more La Nina-like future might actually be right. So you have to compare your models to the paleo science. So now we get to Professor Tim Lenton. He's going to be the hero of this video, because number one, he has a famous ancestor who was a suffragette, and halfway through his online talk about tipping points he mentions the importance of Greta Thunberg and of Extinction Rebellion. And one of his slides show, for example, the risks of political revolution, the risks of the collapse of civilization, which he thinks is in danger of happening in decades, as the Count Everything channel identified in its previous video. So he's looking at the Atlantic meridional overturning circulation current. This is a current, it goes across the whole of the most of the Atlantic, and it transfers warm water up to the cold polar regions. It's an important part of the weather in the east coast of America and in Europe. Now, I've read a research report that was like a summary of all the other research that's been carried out looking at this current, because it's been a concern for some time. And with these reports, they take years to write, and every sentence in the report, more or less, was reference to a piece of research, and that piece of research probably took years to make. Dozens or certainly several climate experts or experts in ocean currents examining it. Maybe they spent their lives studying this. And if it wasn't every sentence had a reference, certainly every paragraph. And reading it, there's so much natural variation, it's quite difficult to tell if what we call it the AMOC, that's what the scientists call it, whether the AMOC really is in decline, if it's slowing down and it will stop transferring this warm water to the north, or whether it's just natural variation. But let's see what the United Nations says. The Atlantic meridional overturning circulation is very likely to weaken over the 21st century for all emission scenarios. That's a case, I think, where the United Nations is being bold in its prediction. So they don't always be conservative about these things. And while there is high confidence in the 21st century decline, there is only low confidence in the magnitude of the trend, because there's so much natural variation. If such a collapse were to occur, it would very likely cause abrupt shifts in regional weather patterns and water cycle, such as a southward shift in the tropical rain belt, weakening the African and Asian monsoons, really important weather systems, and strengthening of the southern hemisphere monsoons, and drying in Europe. This is an example though where the scientists get so far and then they stop, which is why I've been making my videos about the collapse of civilization or human extinction, because not because they're necessarily going to happen, but because people say they might happen, but they never explain how or what it would mean in practice. Well, Tim, the hero of the video, he doesn't stop there. He's the director of the Global Systems Institute, so he has a team of people, he knows what he's doing, and he's investigated this. So an innocent line like the drying of Europe, hidden in the middle of a 2,500 page United Nations report, do you know what that means? It'd be, in Britain, it would mean no agriculture, or much reduced agriculture, and not enough water, or in fact possibly no water, for any of the tens of millions of people who live in the southeast of England. So the United Nations is being accurate, it is telling us how serious it is, but they never go the extra mile, do they, to really ram it home with what it would mean. So Tim's looking into this, and he's trying to predict a way, he's trying to find a way how we could predict if the AMOC was going to collapse or any other weather system is going to collapse. And this is what he's doing. He says if you monitor something to do with the an Earth system, for example how quickly the ice sheets are melting, or whether the El Nino or La Nina is going to suddenly change, or the AMOC is going to collapse, you measure maybe the strength of the current in certain parts of the Atlantic, and you get the usual zigzag line because there's lots of natural variation. And then you look for two things. First of all, you look for the variance, which is how much it's varying, and then you look for what's called autocorrelation, and you see the normal rate at which these things vary. And he says when you have a system that's about to collapse, the normal environment around it that sort of kept it doing what it normally does, whether it's the amount of rain you have or the strength of an AMOC current, those things that it interacts with all the time become weak, and that means when you do have a variance, when you do have a change to but just part of natural variation, it's much more lethargic in going back to its old ways. So for example, last year in Britain we had one day of 40 degrees Celsius. It was all in the newspapers. The next day everyone had forgotten about it, and now I've got my thick winter coat on. So we have some hot days, you have some cold days. That's fine. I think Tim would think as we get to a place where maybe Britain's climate was going to change significantly, as like a tipping point, a massive transition to a new state, instead of having just one 40 degrees Celsius day, we might have several in the course of a month or in the course of a year, and then we would go back to normal. So even though we say, well, we're normal now, we had several 40 degrees Celsius temperatures in the summer, but now we're back to normal, because you had this extended range of extreme weather events, whereas maybe you only used to have one or two in a year. That would be a sign that the systems that keep things in place are becoming more lethargic, and you could reach a tipping point where you were about to transition. Scientists are becoming less reliant on the models and trying to think of new ways to spot how changes might happen. Professor Tim Lenton says what you do is you have maybe 10 computer simulations of different scenarios, and then you get the graphs, and they maybe predict changes in variance and change in autocorrelation as the systems have become more lethargic. And then when you monitor it in the real world, you keep comparing it to your 10 different scenarios, and you see which scenario the real world matches the closest, and then you can say, this is the way we're going. So far, I think, although the video is all about is there a problem with climate science, is it all wrong, I think it's fair to say the scientists are doing their best. They're up front about how difficult it is to look into the future. They're finding new ways to cope with the weaknesses in the models by storylines, or by trying to look for patterns in the variance and the autocorrelation of the Earth systems to try and look out for tipping points. But there are concerns now that maybe even the fundamentals that all climate science is based on are wrong. It's quite difficult to look back at the paleo science, the paleo climate, and even if we did, because the humans are heating the Earth so quickly, we've never seen anything like this in the climate record. But we'll see in the next video how Professor James Hansen has some concerns, and all of his concerns fit right in with the expected ranges of the United Nations predictions. So they'd be in the very likely range. It's a small change to what the United Nations is predicting, but then those predictions are made by humans. Professor James Hansen is coming up with a different way to interpret those, the climate science, which are still right in line with the expected ranges. And the small difference would mean in practice that instead of heading for maybe 3 or 4 degrees Celsius or 2 or 3 degrees Celsius warming, we could be heading for 7 to 10 degrees Celsius of warming. So if you want to find out what that's all about, you'll have to tune in to the next exciting episode of just how wrong is the climate science. So that's the end of the video really. Thank you for watching. Feel free to share and to leave a comment and all that sort of stuff. But apart from that, thank you very much and see you next time.